Standard plant procedures. Boiler room equipment operates continuously to provide heat or steam for process. Boiler operators work shifts to maintain continuous operation of the plant. During a shift change, a boiler operator relieves the previous operator by taking over the shift. Standard plant procedures are established and followed to assure continuous, safe, and efficient operation of the boiler during a shift change. Although procedures vary depending upon the size and function of the plant, certain procedures are common to all plants. Communication with boiler operator relieved. When taking over a shift, the boiler operator must report to work early enough to allow time to check with the boiler operator on duty. Any unusual events or conditions that have occurred during the previous shift are discussed. The boiler room log is then checked for any extraordinary conditions or instructions. A tour of the plant will help identify potential problems. Boiler water level. The water level of boilers online must be checked first by the boiler operator taking over the shift. The normal operating water level, or NOWL, is indicated at approximately 1/2 of the gauge glass. Accuracy of the water level in the gauge glass is assured by blowing down the water column and gauge glass.
The blowdown valve on the water column is opened. This prevents any debris from the water column from being carried into the gauge glass. Water and steam should discharge through the water column blowdown valve to a drain for 5 to 10 seconds. The water column blowdown valve is closed and water should return to the gauge glass. The water should return quickly and flow without interruption. The gauge glass blowdown valve is then opened to discharge the water from the gauge glass. With the gauge glass blowdown valve open, close the top gauge glass isolation valve. Water should flow freely from the gauge glass out the blowdown valve. Next, open the top gauge glass isolation valve and close the bottom gauge glass isolation valve. Steam should flow freely from the gauge glass out the blowdown valve. Open the bottom gauge glass isolation valve and steam and water should flow freely into the gauge glass. Finally, close the gauge glass blowdown valve. The water should return quickly to the gauge glass and flow without interruption. The water level in the gauge glass can now be trusted as accurate. If water returning to the gauge glass rises slowly, there is debris or mud in the piping. The water level reading on the gauge glass cannot be trusted. Water column and gauge glass blowdown procedures should be repeated until water level accuracy is ensured.
Running auxiliaries. Running auxiliaries are the operating equipment not attached to the boiler. This includes feed water pumps, fuel oil pumps, draft fans, and other equipment. Running auxiliaries must be checked for proper temperature, pressure, lubrication, and indications of possible malfunction. Overheating or excessive noise and vibration are indications of a potential problem. Early identification of a problem can eliminate or reduce equipment damage and repair costs. Flame scanner. The flame scanner verifies or proves flame in the burner. It stops the flow of fuel if fuel is not ignited during burner startup or if a flame failure occurs. Flame scanner testing frequency will depend on local requirements and plant operating procedures. The flame scanner is commonly tested for proper operation using the following steps. 1. With the burner firing, the flame scanner is removed. 2. The scanner eye is then covered to simulate a flame failure. 3. The fuel valve should shut off, sounding the alarm. The burner control should begin a post-purge cycle to remove any residual fuel from the furnace. 4. The flame scanner is reinstalled. 5. The programmer is reset and checked for proper operation. Low water fuel cutoff. The low water fuel cutoff stops the flow of fuel to the burner in the event of a low water condition. The low water fuel cutoff is tested for proper operation by a blowdown when taking over a shift. Blowdown is accomplished by opening the blowdown valve while the burner is firing. The float or probe in the chamber senses a decrease in the water level. This simulates a loss of water in the boiler and shuts off fuel to the burner. Blowdown of the low water fuel cutoff also discharges any sludge or sediment. A reset switch is activated to restart the flow of fuel to the burner. Boiler blowdown procedures. Boiler blowdown is used to remove sludge and sediment, control high water, control chemical concentration, or drain the boiler for cleaning and inspection. Blowdown is surface, continuous, or bottom. Surface blowdown removes impurities and foreign matter floating on the surface of the boiler water. During surface blowdown, the amount of water removed from the boiler is controlled by the boiler operator. Continuous blowdown maintains the proper chemical concentration in the boiler water. Continuous blowdown is performed automatically and removes controlled amounts of water. Bottom blowdown removes sludge and sediment that settles to the bottom of the drum. Bottom blowdown is best performed during light loads. This allows the maximum amount of solids in the water to settle to the bottom of the boiler drum. A blowdown pipe fitted with a valve or valves is located at the lowest part of the water side of a fire tube boiler or the mud drum of a water tube boiler.
Steam pressure and water level must be maintained during blowdown unless the boiler is being drained.
Boilers should be blown down at least once every 24 hours. Boilers operating at over 100 psi must have two bottom blowdown valves. These are two screw valves or a screw valve and a quick opening valve. When performing a bottom blowdown, the boiler must be under light load. The water level should be at the NOWL. If a quick opening and screw valve are used, open the quick opening valve first. The quick opening valve is closest to the boiler. The screw valve is then opened slowly to the full open position. The screw valve takes the wear and tear of blowing down. The water level in the gauge glass is carefully monitored during blowdown by the boiler operator. The gauge glass must show water at all times during blowdown. The boiler operator must never walk away from the opened blowdown valves. When blowdown is complete, the screw valve is closed first. The quick opening valve is closed last. The boiler is blown down without steam pressure if the boiler is to be drained. Low water condition procedures. A low water condition occurs when the water in the boiler is below the NOWL as indicated by the gauge glass. Some plants have an audible alarm and light to signal a low water condition in the boiler. A low water condition can result in damage from overheating to the boiler drum, furnace, and tubes. If water cannot be seen in the gauge glass, the tricox must be used to determine water level. If water comes out of the middle tricock, the gauge glass is not functioning properly. If water comes out of the bottom tricock, water may be safely added to the boiler. If water is not present in the gauge glass and steam comes out of the bottom tricock, water must not be added to the boiler. Secure the fuel immediately. Adding water could cause a boiler explosion. If more than one boiler is online and one boiler has a low water condition, the fuel to the burner of the boiler with low water must be secured. The NOWL of all boilers online must be monitored. Feed water to the boiler in question should be secured if the water level cannot be maintained in all boilers in the system. Whenever a low water condition occurs, the cause must be determined. The boiler should be removed from service and inspected. High water condition procedures. A high water condition occurs when there is an excessive amount of water in the boiler, as indicated by the gauge glass. The gauge glass should be blown down to assure an accurate reading. If the water level is still high, the water level is checked using tricocks. Water discharging from the top tricock confirms a high water level in the boiler. The immediate danger with a high water level is the possibility of carryover of water in the steam.
This can result in the rupture of steam piping, fittings, and damage to steam equipment and turbines.
In the event of high water, a bottom blowdown is performed to bring the water level to the NOWL. The burner firing rate should be reduced. After the boiler has returned to the NOWL, the cause of the high water condition should be determined and remedied. Furnace explosion procedures. A furnace explosion is the instantaneous combustion of highly flammable gases or vapors accumulated in the furnace. This accumulation can occur from leaking gas or fuel oil or a flame failure. Any signs of leaking fuels must be addressed immediately. The flame scanner should be checked for proper function. Before relighting the burner, the programmer must go through the purge cycle. If the cause of the furnace explosion cannot be determined, secure the fuel to the burner and notify the proper authorities. Boiler startup procedures. Boiler startup procedures will vary and are based on the size and type of equipment in the plant. Boiler startup procedures are classified by the status of the boiler as a cold plant or live plant. Some boiler operators refer to cold plants as dead plants. Cold plant startup procedures are performed on boilers that have been out of service for more than 2 days. Live plant startup procedures are performed when starting a boiler with other boilers online. If plant procedures are not specified, the manufacturer's boiler startup procedures must be followed. Boiler shutdown procedures. Boiler shutdown procedures are required to safely take a boiler offline. All loads affected by the shutdown must be covered by other boilers. Procedures required for boiler shutdown include the following. 1. Secure the fuel to the burner. 2. Reduce the draft to the furnace to allow slow cooling of the furnace.
3. Close the boiler main steam stop valves after the boiler has stopped producing steam and open all steam line drains.
4. Open the boiler vent when the steam pressure is down to 25 psi. This prevents a vacuum from forming in the boiler. 5. Maintain the NOWL as the boiler cools. 6. Shut down the feedwater pump and feedwater system when the boiler has cooled down sufficiently. Boiler room log. A boiler room log records the temperatures, pressures, and fuel consumption of the boiler and auxiliaries in the plant over a 24-hour period. Boiler operator duties may also be listed in the boiler room log, including blowdown of gauge glass, water column, and low water fuel cutoff, testing of the low water fuel cutoff and flame scanner, and maintenance work completed. Boiler room logs commonly use pre-printed forms with data added by the boiler operator on duty. Extraordinary events which occur must be communicated to the chief engineer using the boiler room log or other communication. Depending on the plant, this can be done verbally, by memo, by telephone message, or electronic mail. Many plants use a personal computer to record boiler room log information. This information can be used for developing long-term plant operation records. Some plants have burner control systems which use a computer to process information received from sensors located throughout the plant. For example, steam pressure sensors send information to the burner control. This information is recorded with the time, temperatures, and pressures present at the time. Accurate documentation of plant operation data is required to maintain plant records. These records provide data for assessing plant efficiency, troubleshooting activities, insurance requirements, and compliance with environmental regulations. Plant efficiency can be determined by the amount of steam generated and fuel used. Troubleshooting activities identify unusual changes in the operating characteristics of the plant. Insurance companies often require plant operation data which details boiler operation, maintenance, testing, and inspection activities. Environmental regulations may require documentation of flue gas temperature, draft, smoke, excess air, carbon dioxide, and carbon monoxide. Review. Standard plant procedures are established to assure continuous, safe, and efficient operation of the boiler during a shift change. The water level of boilers online must be checked first by the boiler operator taking over the shift. The low water fuel cutoff is tested during a shift for proper operation by blowdown. Boilers should have a bottom blowdown at least once every 24 hours. If water cannot be seen in the gauge glass, the tricox must be used to determine water level. If water is not present in the gauge glass and steam comes out of the bottom tricock, water must not be added to the boiler. Adding water could cause a boiler explosion. The flame scanner stops the flow of fuel if fuel is not ignited during startup or if a flame failure occurs. A boiler room log records the temperatures, pressures, and fuel consumption of the boiler and the operation of auxiliaries in the plant. This video depicts boiler operation procedures commonly practiced in industry. Boiler operation procedures vary from plant to plant. For maximum safety, always refer to specific plant procedures and applicable federal, state, and local regulations.